Greetings, just a very quick video to show you how to use your calculator to do problem 7 from the practice problems for section 9.5. So this is how do I do complex numbers on my calculator. So as you can see, it says up here in the instrucciones, it says simplify each of the following and write in the form of a plus bi. That's important. They don't want you to just write down a number. They want that number in the form of a plus bi. So make sure that you recognize that. Okay, so cool thing about it though is we don't have to get too worried about that because our calculator, when we use it to do these calculations, will give back the answer in a plus bi format, provided that we tell it we want to do it that way in the first place. So you press our mode key as per the instructions up there, and you may still be in real mode, and we're going to get rid of that, and we're going to switch over to the complex numbers. So we're going to go over to a plus bi mode, which says I want to work in the complex numbers. And then I'm going to do a second and a quit, which is a second mode to get out of this. And now, say for example, if I go second square root of -4, it's not going to throw me an error as being not a real number. It tells me that that's 2i. So we're now working in the complex numbers, and calculator's all happy about that. So let's go ahead and work through these real quick. So the first one, the square root of -81. Well, we're going to go second square root of -81, and hopefully that's going to come out to be 9i. By Jove, it is. Okay, so coming over here to our actual document here, get my pen in the right position here, we would write down that -81 is equal to 9i. Now, if we want to write that as in a plus bi format, that would be 0 plus 9i. But generally speaking, we're not going to have to do that. Okay, so square root of -11. So we're going to go second square root of -11. And this time we're going to have to round off because 11 is not a perfect square. So square root of -11 is approximately 3.317i. Okay, if we go out 3 places. All right, now we're going to go ahead and do some other arithmetic operations with complex numbers. Turns out it's fairly straightforward. If you just dealt with I like it was x, just pretend that I is x with just one little sort of strange property, and that is that I squared is equal to -1. Then besides that, it's going to work out pretty much how you would expect. So for example here, this is 4 minus 2i minus 6 minus 8i. And so all we have to do is think about collecting like terms. So that gets me minus 2, that's taking my real parts, the 4 and the minus 6, minus 10i. In other words, I add the real parts and I add the complex parts together, or the imaginary parts, and by Jove, we get the same number. So let's try that in the calculator to make sure I'm not lying to you. So we'll go parentheses 4 subtract 2i. I is a second function right above your period, and that's where you go to get that. And then subtract from that, parentheses 6 plus 8i. And lo and behold, we get back -2 minus 10i. Okay, so let's take a look at part D here. So think about using the distributive property here, and we're going to end up with 6i, if I take the 3i times the 2, and then 3i times -4i is going to get me -12i squared. But must remember that I squared is equal to -1, so that is 6i plus 12, because a negative and a negative is a positive, or if we wrote that as a complex number, it would be, let's put them in the right order here, Mike, that's important. We have to always put them in the form a plus bi. In other words, the real part comes first, which is the 12, plus the 6i. Okay, so let's go ahead and speed this up a little bit. I'm just going to start doing the remainder of these on the calculator just to help me out here. So let's go with 3 subtract I times 2 plus I. And we do that, and we end up with 7 plus I. Okay, so just to show you how it actually did that, for the sake of completeness here, is you think we're going to use FOIL. We pretend that this is a product of 2 binomials. So we're going to end up with a 6, and then plus 3i minus 2i minus I squared. Well, we know that I squared is equal to -1, so this is 6 plus I, collecting up my like terms in between the 3i and the minus 2i, plus 1, which is 7 plus I. Okay, so let's go ahead and here into F. Well, we're going to distribute that -3 first, so this will be 4 minus 8i minus 12i. So collecting up my like terms here, I'm going to get minus 8 minus 20i. It's almost faster with some of this arithmetic just to do it by hand than actually having the calculator do it. Let's talk about what 2 plus I squared is. 2 plus I squared is 2 plus I times 2 plus I. And so again, we would end up using FOIL on that. But we're going to go ahead and let the calculator do that one for us just to get some of them in here on the calculator. So we'll go second I, after we get our 2 plus in there, and we're going to go ahead and square that. And we get back 3 plus 4i. I invite you to go through the work of using FOIL on that and collecting like terms and showing that it really does come out to 3 plus 4i. Okay, now at this point we're definitely going to start using the calculator because I don't want to do these by hand. Okay, so let's go ahead and take a look. Well, don't hold me to that. I might change my mind as we go through here. So let's take a look at this one. Actually, I think I'm going to go ahead and do this one by hand now that I look at it. And we're going to say what? That is 4 minus the square root of -8, which is going to be 2 square roots of 2i divided by 6. Okay. See, if I had gone ahead and used the calculator, I would have got a decimal approximation, and that's not what they're looking for. They want us to give them back exact answers here whenever possible. Obviously, we didn't do that up here in Part B, but I'm pretty sure they want us to give them back exact answers whenever we can. All right, now we notice that there is a common factor of 2 between the numerator and denominator. 2 goes into 4 2 times. 2 goes into 2 here 1 time. And 2 goes into 6 3 times. So if we cancel off that common factor between the numerator and denominator, we end up with the following. So just a quick aside here, just to make sure that you got it. We know the square root of 8 is the square root of 4 times 2, which is equal to the square root of 4 times the square root of 2, which gets me 2 square roots of 2. So that's where the square root of -8 became 2 root 2i. Okay, popped out the I first, that took care of the negative, and then the square root of 8 reduced to that. Okay, 1 plus square root of -36 over 3. Well, that's going to be what? That is, if we simplify that radical, that's going to be 1 plus 6i, right? Divided by 3. And almost home, except for, oops, I made a mistake back here. I got to back up to the last one. It's imperative that we write it in a plus bi, and I'm not done because I need to break it up and do that. So this is 2 over 3 minus root 2 over 3i. In other words, the final form of the answer has to be in a plus bi format. Okay, so keeping that in mind, back over here on this one, that means this is going to be 1/3 plus 6/3. Well, 6/3 is 2i. Okay, so let's go get our calculator to help us out with the last one here. We're going to do the stuff under the radical there first. So that's going to be 4 subtract 4 times 2 times 5. And I'm just putting in the stuff that's the guts under the square root to see what that simplifies to, and that simplifies to -36. So this is equal to 2 minus the square root of -36 over 4. Okay, as we just saw, the square root of -36 is 6i, so that's equal to 2 minus 6i over 4, and then we've got to break up this fraction here, so that's going to be 2/4, which is 1/2, and then 6/4, which is 3/2, times I. Okay, so I went through that fairly quickly, but it's hopefully comprehensible, and don't be shy about doing the ones that you can do on your calculator. I apologize for saying do all these in the calculator down on H, I, and J, but yeah, we really want to do those by hand. Okay, let me know if that helps, or if you need anything more, I'll be happy to do more videos.